Hello everyone, let's look at the series here. We have this series 2 to the n over n factorial. Usually when we try to determine whether this series is convergent or divergent, we are going to use the ratio test because it's easier to deal with the factorial when we use the ratio test. But this time I want to use the ordinary comparison test to show that the series is convergent. Okay, so when we use the ordinary comparison test, we actually need to come up with a series that we can compare with this one. Okay, so the one that I'm coming up with, right? So we compare this series with this series right here. It's going to be starting from 1 for the n, and then we are going to compare it with a geometric series 2 to the n over 3 to the n. And yeah, so if we are writing it in the standard form, right? Actually, it still may not be the standard form, but we can write it in a form where we can see the common ratio, which is 2 over 3. And so if you have seen my other videos, I actually have compared with this one before. And so for this one, we know that this is a what? This is a convergent geometric series because the absolute value, the common ratio is the absolute value of 2 over 3, and that's really just 2 over 3, and that's less than 1. So we say that this geometric series is convergent. Okay, so and then you may say, how do we know that whether the turns for this series is larger or the turns for this green series is larger? Um, First, as we can see that they have the same numerator, so all we need to do is to compare the n factorial and then the 3 to the n and see which one is larger. So first thing, we need to just take a look at the n factorial and the n 3 to the n, and we want to see which one actually increases faster when n is increasing. So how do we do that? We can actually just look at a table and then see which one is larger. For the first few values, it feels like we are going to get a larger number for 3 to the n, right? As you know, that if you plug in 3 into the n, we are going to get 3 factorial, which is just 6, but 3 to the third power is already 27. Okay, so let's make a table. Let's make a table here. So I'm just going to do the table on the side and then try to compare them, right? So let's just do that right here. Okay, so I put the n here. Maybe I should use a brighter color. So I put an n here, and then we are going to put the n factorial here, and then I'm going to put the 3 to the n here. Okay, so right now I'm going to put in some n values. So let's just start from 1, and 2, and 3, 4, 5, 6, 7, and 8, and see what's going on. Okay, now let's start filling in the table and see what's going on. So when we are doing the calculation, we have 1 factorial, right? So we are just going to get 1. And then 3 to the first power is 3. And let's fill in the other the columns first, right? So we are going to get 2 factorial, which is 2. 3 factorial is 6. 4 factorial is 24. And then 24 multiplied by 5, you can actually just keep multiplying the next number in there, right? So we are going to get 120, and then 720, and then you multiply the 720 by 6, which is 5040, and then multiplying the 5040 by 8, which is 40,320. Okay, so that looks like a 0, right? So that's a 20. Okay, what about the 3 to the n column? We have 3 squared, which is 9. 3 cubed is 27. 3 to the fourth power is going to be 81. 3 to the fifth power. Actually, we can just keep multiplying by 3 from the previous number to get the next one, right? So we are going to get 2 to the, 3 to the fifth. It's 243. and then multiply by another 3 here, we get 729. And then, so see that at this point, when you get to n equals 6, we still have 3 to the n that's greater than n factorial. But once you get to the 7, we are going to just be getting 2187. Okay, what about the next one? The next one is going to be multiplied by 3. We have 6,561. Okay, so as you can see that the n factorial will grow faster once we get past n to this n equals 7. This is really because when we get to n equals 6, we are having two numbers that are so close to each other. And when we get to n equals 7, for the 3 to the n, we are still multiplying by 3. So each time we are actually just multiplying by 3, right? So you're going to multiply by 3 here. And then next one, you're going to be multiplying by 3. But you know that it's what's causing the n factorial to increase to a larger number, because when we go from 720 to the 7 factorial, we are going to be multiplying by the extra factor of multiplying by 7, right? As you can see here, multiply by 7 to get that. And then what about the next number? We need to multiply by 8. And so that's why in when you go past the 7, you are going to start having the n factorial that's greater than the 3 to the n. So we can say for n greater than or equal to 7, right, we can say that n factorial is going to be greater than 3 to the n. That 3 to the n comes from the green series that we're using it to compare with the series that we're looking at. Okay, so that's that for now. Now, um, for the first few terms, we know that n factorial is going to be greater than that 3 to the n, right? I mean, the 3 to the n is going to be greater than the n factorial. And in this case, it doesn't really matter here because those are just the few finite terms, right? We actually want to see what happens beyond a certain n value. So in this case, um, we know that beyond the 7, we are going to have n factorial greater than 3 to the n. So if we are taking the reciprocal of the, the n factorial and then also the 3 to the n, we are going to obtain this inequality. So let's take the reciprocal, which will give us 1 over n factorial and then 1 over 3 to the n. And then in this case, we need to switch the inequality symbol. So if you have a larger denominator, then that fraction will be smaller. And the next step, because both fractions, they have a 2 to the n in the numerator, so we are going to multiply both sides by 2 to the n. And because 2 to the n is non-negative, then we can actually say that the inequality will still hold here, right? Even if we multiply by 2 to the n. So we are getting 2 to the n over n factorial, and that's still less than 2 to the n over 3 to the n. And yeah, so we do know that's yeah, so that's our green series here. Now, we already know that this geometric series is convergent, and its terms are larger for n greater than or equal to 7. And so that means the series that has smaller terms will also converge. That starting from n is what it's from n starting from 7. And so we can say that by the ordinary comparison test, right? So we call this the OCT. Then what do we say? The series that we have I'm going to set it to be greater than, starting from 7, not greater than, but starting from 7, that our series 2 to the n over n factorial is convergent because it has smaller terms than the geometric series that we chose to compare with the series. Now, the problem is that n equals 7, that series that's at n equals 7, that's not the same series as this one. But just imagine that you are just adding the first few terms, the n equals 1, n equals 2, all the way to n equals 6. You're just adding a few more terms to the series that will not change um, the convergence of the series. You're still going to be getting a finite sum. So adding those few terms um, makes no difference on the convergence, right? So now we can say that the one that starts at 1 also converges. Okay, so that's it for this problem. And if you like this video, please subscribe to my channel and give me some support. And I will continue to make more videos in the future. Thank you for watching. I will see you next time.